You have already a patent?
Yes.
Oh.
Yes, patent.
Okay.
That is, we can produce graphene from biomass. Yeah, that is very interesting because we use not high temperature, but little bit lower. That is not 3,000 degrees Celsius. It's very, very difficult to produce.
So the patent is actually using less temperature.
Yes, because we use a special additive, special material to reduce the temperature process, but the conversion process itself is normal.
Right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Yes, the carbonizers, carbon activists, carbon friends all over the world. Welcome back to another episode of Carbon Forum. With me, Poempida Hidayatulloh as the host. And today, this is going to be very interesting. We've been talking so far related to environment and also carbon credits and also climate change. But then today, it's going to be different. We're going to discuss about carbon as itself, as an essence, as an element, right? So with us, we already have a very interesting expert in this field. He's from Forum Sinergi Inovasi Industri or Industrial Innovation Synergy Forum. His name is Bapak Pudji Untoro. Welcome, Pak, to Carbon Forum. How are you, Pak?
Fine, thank you.
Oh, thank you very much. Thanks for being here.
Yes.
And we're going to discuss about the advanced carbon prospect, right?
Yes.
What is it?
Yeah, carbon is coal, not coal,
It's
but
a sea.
yeah,
It's a sea.
a sea. That is, but in the future prospect is not only carbon itself, but also another material that is specific nano-size structure material.
Yeah.
Because if you know, carbon is charcoal, but there are many structure and also many dimension.
Yeah.
So if we know carbon itself is from charcoal, that is only 10,000 rupiah per kilo.
Yeah.
But if we can produce another structure of carbon, for example, carbon nanotube, and also another thing is graphene. This is the price is $70 until $300 per gram.
Per gram. Wow. Yeah,
That is very interesting price for the future. But this is, I would like to know, I would like to tell about the specifically graphene structure itself.
Let's move a little bit backwards.
Yeah.
And, carbon in the nature, normally we will find it as an hydrocarbon, right?
Yes.
And then if you burn it, then you can have the carbon on its own.
Carbon.
Right.
Yes.
That's why we got charcoal, we got all these burnt material as the carbon itself. So what is the purpose of carbon actually? Because if you sort of deactivate it, then you can use it to absorb a lot of smells or any gases and even CO2, right?
Yes.
So you can actually use deactivated carbon as what you call it, as an absorber, for the CO2, right?
Yes.
So what do you think on that?
Yeah, that is interesting one. The carbon is also as an absorber. But if we can convert to graphene, that is not only absorber for environmental friendly application, but also for water absorber, the water filtering.
Okay, so graphene can be used as an absorber also,
yes,
right?
Yes, of course, because the structure of graphene itself, that is only one layer atom.
Yeah.
One layer atom. The diameter of carbon atom is 2.7 nanometer.
Yeah.
And minimal molecule of water is 2.55 nano. So if we can produce the filter using graphene structure, that it only water can flow through.
All the other materials will be left out, right? That's good. And You know, graphene is an hexagonal sort of shape, structured from carbon, right? From carbon chain. I heard there are a lot of benefits for using graphenes, but it's not easy to actually manufacture it, right?
Yes, that is really not easy. Now it's so that the price is very, very high.
Yeah.
The produce cost is also very high because we must also peel up the structure from graphite.
So it's only one layer.
Only
right?
one layer.
I saw some sort of demonstrations in YouTube, and then normally you can use the graphite from pencils.
Yes.
And then you use some sort of sellotape.
Isolation.
That's graphene, right? You can create graphene.
Yeah.
It looks straightforward, but then if you want to produce it in a mass production sort of way, it's going to be
it's very difficult.
Difficult, right?
Yeah. Yeah.
So how are you going to develop this in the future for the industry?
Yeah. For the future, we have also finished the patent. We cooperated with Brins researcher.
So FSII.
It's
you have already a patent?
Yes.
Oh.
Yes, patent. That's it. We can produce graphene from biomass.
Oh, okay.
This is very interesting because the biomass structure is unique structure. Every biomass, every tree, every material of biomass is very interesting structure.
Explain to me the process from this biomass to graphene.
Yeah. From the biomass to graphene, at first we burn the biomass for the temperature about 1,000 degrees Celsius. That is very high
1,000
temperature.
degree.
Or without oxygen. No? That is not burn without oxygen. So that
how do you burn without oxygen?
We can use also inert gas.
Oh, inert gas. Okay.
Or we can also produce using plasma technology. Yeah. Yes. The plasma, we can also find also the high temperature and also free oxygen environment.
Yeah.
So that we can
So it's not consuming oxygens from the air.
Yes.
That's the most important thing. So it is actually environment friendly, right?
Yeah. Right.
Okay.
And then we can produce from graphene to charcoal.
From graphene?
No, from biomass.
Sorry.
Biomass to charcoal.
Okay.
And then we can produce after using higher temperature. That is about 2,000 degrees Celsius. The carbon structure convert to the graphite structure.
The graphite first.
Yeah.
Okay.
If we find also the graphite structure, also we can also really the end product of the end material for the graphene process after that.
Right.
And then we can also find the graphenisation process. We need also more higher temperature. That is about 3,000 degrees Celsius.
You said that the price is $70 per gram. Up to 300.
Yes.
Okay, let's say $70 per gram, right? And then who buys this?
Now as the possibility future business is growing up now, because, for example, in the structure, beton structure,
concrete,
concrete structure. We can also additive add using graphene
only to strengthening. Yeah, because I heard that the tensile strength is quite high.
200 times more than steel.
200 times more than steel. Yes. What about the compressive strength? Compressive strength and tensile strength, both.
Yeah, tensile strength is depend also on the structure, graphene structure and micro.
Okay.
Yeah.
Wow.
That is very interesting. So if we can produce the beton structure using graphene,
concrete structure.
Concrete structure using graphene,
improve the strength.
Improve also the strength, but also reduce the cement use. Yeah.
But cement price is a lot less than graphene price, right?
Yeah, but the graphene's additive is only 0.1 until 1%.
Oh,
of the
I
mixing
see, I see.
processing. Yeah.
I see. So the cement will be a lot less.
Yes.
Okay. All right. Right.
But
Yeah,
also
it's very
beton
interesting.
also
The concrete.
steel also maybe more less than normal
Oh,
structure.
the supporting steel,
Supporting
you
steel.
can use
Yes.
less supporting steel. Wow.
Yes.
Wow. That's very interesting. What about the response towards low frequency? High frequency sort of vibrations. Like for examples, what you call it, earthquake or anything like that.
Yeah.
That actually the one that destroys buildings, right?
Yes, right. That is maybe a little bit different because the graphene itself is only strength structure.
Yeah.
But we don't have. I don't have any publication.
You haven't done any sort of research on what you call it, creeping or fatigue or any kind of sort of failure.
Or microwave. Reduce microwave.
All right. Well, it's very interesting. So, do you think we can actually produce it in the future? I mean, looking at the raw materials, I mean, biomass so abundant in Indonesia, right? So, do you think Indonesia can be one of the players for graphene in the future?
Yeah, maybe if we can, the government intends also in the area of the advanced materials in the future. Maybe I think we must also prepare for the future also, because if we produce only this material, but the other material, the raw material, more and more export it to abroad, I think for the future we must also little bit thinking about it.
Right. You mentioned about the patent. What sort of patents that you have, and can we actually utilize it?
Yeah, that is very interesting because we use not high temperature, but little bit lower. That is not 3,000 degrees Celsius. It's very, very difficult to produce.
So the patent is actually using less temperature.
Yes, because we use a special additive, special material to reduce the temperature process, but the conversion process itself is normal.
Right. You already received the patent, right?
Yes.
So if I use your technology and I have to pay you some sort of, money for using the patent, right?
Yes. We start also to grow the microfabrication.
Okay.
Yes, microfabrication, microfactory. We have, I have also microfactory in Malang, cooperated with ITS. Now we can produce the graphene structure, so about 6 kilogram per day.
Per day.
Per day.
6 kilogram per day, multiply by, let's say $70. How much is that?
But the
you make a lot of money. Make a lot of money.
Yeah, if the market is big, maybe from the future. But now the Indonesian itself they don't have they don't know about the graphene and so on and application.
You said the production cost is high also. But from the $70 per gram, you still make money out of it?
Yes. Okay. We can also sell $70 per gram, but the quality is a little bit more than normal price.
I see. That's good.
The difficulties is the factory application factory is today is no possibility in Indonesia. But in Indian, some people call us to make a sample to make answer. But that is very dangerous because if we sell abroad and we can also the physical properties and also processing procedure and so on, we can know more.
I think it's best to sell a finished material instead of just half done material, right?
Yes.
So, well, Pak Pudji, is very interesting what we talk about. And can you actually address a few words to the audience, please, by all means?
Yeah. the audience, this is very important for the future. We must also innovate by ourselves raw material in Indonesia for the future technology application. So if we don't go to the right direction for the future, I think Indonesia is only importer nation.
So importing nations.
Nation, yes. Thank you very much.
Okay, thank you, Pak Pudji. Thanks for being with us. It's been very interesting, and we will definitely invite you to our seminars or any kind of activities that we do. We are from the Association of Carbon Expert in Indonesia, and hopefully we can actually do something for the development of graphene and all. Thank you very much.
Thank you also, Pak Poempida. Forum Carbon Indonesia is good.
Cool. Thank you, Pak. Well, the carbonizers, carbon activists, carbon friends, that was Bapak Pudji Untoro, and he just explained about the importance on developing high-tech materials. It is called graphene. I'm also a fan of graphene. It's been a while I studied this graphene, and for me, it's a very sort of interesting and amazing sort of stuff. And might as well, if the value in terms of economy is there, why not we're pursuing it? So always stay tuned with Carbon Forum with me, Poempida Hidayatulloh, until the next episode. Wassalamualaikum warahmatullahi wabarakatuh.